Okay, so this idea of 68, 95, 99.7 will actually only work if like we are like 1, 2, 3 standard deviations away. But if we're not, then we actually have to like come up with some kind of way to measure the area, say between here and here, like say 90 and 100. And so how do you measure that area? And so what we do is we actually use a mathematic formula. What that does is it takes it's called a z-score, and so it takes like the mean of 100 and makes it a mean of 0, and the standard deviation of 15, and it makes it calls it 1. And so what these numbers actually represent when the average is 0 and standard deviation is 1 is how many standard deviations away you are from the average. Like, you know that between -3 and 3 it's 99.7, but like between -2 and 1.5, like we don't really have a way to tell that. But so that's what the z-score is it tells you how many standard deviations you are from the average. So that's helpful to know. The formula to kind of create it is like to create every number to become a z-score is just take the score, subtract the average, divide by the standard deviation. And so then what the curve still maintains the same shape, except the average is now 0 and the standard deviation is 1. What that does is it takes things from like apples and potatoes and IQ scores, and it makes everything a standard normal distribution chart where an average is 0 and a standard deviation is 1. Okay, so let's look at an example or a chart that like um, looks at what the areas are. And so like this is just a Google image search. You can find if your standard deviation is a certain number, like what area is less. A different Google image search, if your standard deviation is a certain, or if your z-score is a certain number, what area is less. And so generally they are like they give you the percentages that are less. And so let's look at actually how to use it. Um, so if we had a z-score of 0.82, let's look at the example. A 0.82 z-score would be like not quite one standard deviation above the average. And so like what that would mean is like you could actually find the percentage that's below the number using like one of these charts. And so like 0.82 using this one is z equals 0.8, and then go over to 2, and it's this number right here. Like using this chart, it's 0.8, and then go over to 2, and it's this number here. And so like the answer for that is 0.7939. So if you had a z-score, and we'll look at like actually converting it in a second, but if you had a z-score, that's 79.39% of the data. The z-score is that's at the 82nd percentile. So 82nd percentile represents the number that's higher than 82% of the data. It's in here. So the z-score is kind of right in the middle of these two. It's 0.915. So right in the middle here would be 0.915. That's a Z value. That's not a percentage. That's a Z value. So your Z score would be 0.915. The percentage that's above Z equals 0.91. So let's look up 0.91. Would be 0.91 would be 81.86%. So that means that the rest is below. So 1 minus 0.8186 would equal looks like 18.14%. So 18.14% of the data is higher because these numbers are always less. And then the percent that's between, we'll do that one in a second.